So what I was saying, excuse me, this actually fine. What I was saying was, this is where I got with the programming. I've only been, it's super important to understand. I spent most of my life trying to learn how to program, and I never could teach myself. Because learning code was a language, and it's really hard to learn a language. Like, to learn another language by yourself is difficult. Like, imagine trying to learn Japanese without speaking to people that know Japanese. Like, how would you know that you understand the language without feedback? So I've only been doing C++, apart from when I first started doing it in Fullsail. I've only got maybe 5 or 6 real weeks of experience with programming at the moment. And even though it might be 5 or 6 weeks, like the time that I've spent in the language, the actual hours spent are significantly less, because half of my time, let's say 3 weeks, and then let's say half of the 3 weeks, 1/3 of the 3 weeks was spent to sleep, because you should sleep for about 8 hours a day. So that's on a, because I know I'm not sleeping 8 hours, but let's say on the higher end of that, I take another third of the 3 weeks. Then I've only got about maybe 6 weeks total, and then half of that was probably spent doing everything other than programming. So that gives me 3 weeks. And then of the 3 weeks, let's say 1/3 of that time was spent just asleep. So I've only been realistically learning. I've only spent about 2 weeks, realistically about 14 days. I'm only about 14 days in learning C++ code. And where I am right now, what I'm struggling with is not functions. This says function, but I'm not struggling with function. I'm struggling with methods. So this is where I was when I got at the end of week 2. This is where I was at, and I had finally reached a place where I was like, okay, I'm actually learning. My learning curve is there. I can feel myself understanding what's going on, and the information I'm retaining information better, because I'm able to have a work sleep study cycle, which is good. And I'm understanding what I'm doing. I'm seeing the code is making sense. I don't understand the full structure of a method yet, but I'm moving in the right direction. And then when the teacher gave me 200s and a 0, it's like, why do you have to be an asshole? Why do you have to make things harder than it needs to be? Like, you could just give me a 61 as a passing grade. He could have just gave me a 61 and been like, hey, I can see that there's some progress here, but it feels like you're cheating. And I don't want to accuse you of cheating, but I can see that there's some progress, but I also feel like there's something underhanded going on. Your experience seems to be higher than what it should be. You're learning, you're turning in assignments that are completed, but it doesn't feel like you understand. And I would say I don't fucking understand. I'm not exactly confident of what it is that I'm doing, but you only gave me 2 fucking weeks. So within the time frame that I have, I'm using what I know to get through this course, because I need to pass the course to learn the things that I'm trying to learn, to get the information from you that I need. So, but to give me a 0 is like, oh, you're just bullshitting. You're not doing anything. You're just making shit up. You're just pasting into ChatGPT and then turning in your assignments, and we don't reward cheating. That, to me, that's the conflict. That's the problem. I don't deserve a 0. I deserve, at the very minimum, a passing grade, a 61, at the very minimal, because the learning is there. Well, if it wasn't for ChatGPT, you wouldn't be able to learn how to program anyway. You wouldn't be able to do it. No fucking shit. If ChatGPT didn't exist, my instructors would have to teach me. They would have to actually teach me the shit. The reason why I'm recording this video and the reason why I'm engaged in this is because my 2 cents has always been about self-education through self-improvement because of this resistance. And ChatGPT, as an empirical based data set, as an actual peer reviewer, right? Because what is the most important part about science? Someone able to stand over you and say, hey, what you're doing is valid for these reasons, what you're doing is not valid for these reasons. White people stand over black people and say, you're not good enough because of your skin complexion. Let us engage in manipulation and disrespect and gaslighting and narcissism and all the other bullshit that society says exists. Let's do these things to you based on your skin complexion to show that you are not competent. And then when it happens to us, everyone outside of that says, well, maybe you need to understand that it's possible that you may or may not actually be qualified. Maybe you should just be humble and accept the fact that you should just be a janitor. Maybe you should just be humble and accept the fact that you're autistic. Maybe you should just be humble and accept the fact that you have a learning disability. Maybe you should just be humble and accept the fact that you're on a spectrum. Maybe I understand my brain and what's going on inside of my head, and I can feel when I understand something, and I can feel when I don't understand something. When I communicate that this is an area where I'm strong and this is the area where I'm weak, and you have the information that I need to have, maybe you should look at me with humility and say, let me focus on this area that he's weak in to get him from where he is weak to where he can be strong. Maybe that's what should happen. And ChatGPT can do that. ChatGPT is able to do that shit. Because when I was watching this video,
finally, functions may optionally have an access modifier or static definition. A function may also be referred to as a method within an object-oriented programming language such as C++. Here you can see an example of a C++ function also known as a method. This highlighted section is known as the parameter list. Parameters are data points that can be passed to the body of a method. They must be defined within the parameter list of the method's head with both a type and an identifier. Executing a function is also known as calling the function.
There's another part. This is
calling
actually
the function or method refers to executing a predefined method somewhere within your code by referring to its identifier and optional parameters. Here, you can see we've called our sum method and passed it two literal integer values, a 4 and a 5. That 4 and 5 will be assigned to the number 1 and number 2 parameters, and then added together to calculate our sum variable. When we pass values to our function when it's being called, these values are known as arguments. The method definition specifies names and types of any parameters that are required, and when the calling code calls the method, it provides concrete values called arguments for each parameter. Arguments must be compatible with the parameter type, but the argument name, if any, used in the calling code doesn't have to be the same as the parameter name defined in the method. So again, here you can see I've passed a 4 and a 5. These values here are known as arguments that are being passed to the method. When they're inside of the method, they are the parameters that have been passed and will be assigned to, again, number 1 and number 2 respectively. Again, it doesn't matter what these arguments are called. So here you can see I have num1 and num2. The value stored in num1 will now
remember,
be
the
stored
whole
in
point
number 1.
is this idea that I'm not doing any actual work, that I'm just bullshitting and trying to cheat my way through life.
The value stored in the
And it's disrespectful, and it's super hypocritical. I want you to see
one argument
this,
will now be
right?
stored
Because this is going to become relevant here real
The order
soon.
in which you pass arguments to your parameter list is important because they'll be assigned in the order that the parameters in the parameter list have been defined. Arguments will work the same whether your method is being called on a static method like it is here, or on a method that's local to your class, as we showed in the previous slides. The static modifier is used to declare a static member, which belongs to the type of the class itself rather than a specific object. Up until this point, and for at least the next few days, you'll be dealing exclusively with static methods. It's important to remember here that classes have two particular purposes. One is a logical grouping of code, typically methods, and the other is to instantiate objects. Again, we'll talk a little bit more about objects in week 3, but for now, just recognize that all of the methods that we are creating and calling will be static. The public keyword here is known as an access modifier. Access modifiers refer to whether or not a particular piece of code can be accessed from another part of your project. For the purpose of this course, it will primarily refer to whether or not it's accessible within another class. All class members have a particular access by default that may vary, even if one is not explicitly defined with an access modifier. So by default, in C++, when we define a method within a class, it will be marked as private if no access has been defined. Public members can be accessed outside of their parent classes, but private members cannot be accessed outside of their parent class. This portion of our method is known as the return type. The return type of a function or method determines the type of value returned by the method. This corresponds with the function or method's return statement. If no return is needed, a return type of void must be defined. Functions or methods with a void return type may also be referred to as a procedure. So here you can see that our method is going to return an integer type value, and that has been explicitly defined within the method's head before the identifier. And here you can see the corresponding return statement. The return statement of a function or method identifies the point within the body where a value can be returned. If a particular return type is defined, the value returned by the statement must match the defined return type. Failing to do so will result in an error that says not all code paths return a value. A return statement will terminate the function's process, and as a result, no code after the return statement will be read. Using a single return statement within the function or method is best practice for this course. So again, you can see that our method requires an integer return type. When we take in our two parameters, number 1, number 2, we'll add them together and we will assign them to our integer typed sum variable. Then we'll return our sum variable, which will be the result of calling this method and passing those arguments. Scope refers to the part of a program where a particular name or identifier is valid. In this particular case, our integer sum variable is initialized within our sum method, and as a result, it would not be accessible outside of our sum method. Typically, you can visualize the scope of the data by paying attention to your curly brackets. So here, within these curly brackets, my integer sum value is within scope, but if I were to try to call it outside of the curly brackets, I would get an error that says the sum name does not exist in the current context. Here we can see another example of a person class that contains a string variable as well as a public string getName method. Since the getName method and the string variable both exist on the same level within the curly brackets, I can access my name variable from within my getName method. This is one of the many reasons why it's important to make sure that you're keeping track of your curly brackets as well as maintaining proper white space within your code. Both of these things help us visualize where our values are available. This portion of code, known as the head, is also known as the method signature. A signature of a method is a unique piece of code that defines the purpose of a method. At minimum, it includes the method's return type, identifier, and parameter list, but may also contain access modifiers such as our static keyword here. As the definition implies, nowhere else in the current code structure, that is probably a class in this case, can I have another static int sum variable that takes in two integer parameters. However, there are some special cases for methods known as method overloads. In C++, an overloaded method is a method that shares the same identifier but has a different parameter list, return type, or both. Here you can see I have another static int sum method. However, rather than taking in two integer type parameters, it takes in 3. Similarly, I can also have it take in two double type parameters instead of integers. Hey guys, in this video we're going to talk about methods in C++. So methods are really useful because what they do is they repetitive in our code and encapsulate them into just one reference point and put them, somewhere else that we can just call over and over and over. This is very, very common in programming. It is very, very helpful for keeping our file size down, keeping it easier to maintain, make it easier to read, all kinds of different things, right? So we'll take a look at what that looks like here. We're going to look at different types of methods, some methods that actually return some type of data, some methods that actually don't need to return any type of data at all, some methods that accept data and stuff like that. So a really common thing that we're going to do in, at least in this particular course, is reading and writing from the console a lot, right? So for instance, let's say I wanted to create a really kind of more fleshed out console application. So first of all, I would need to make sure that I have IO stream in here. I also am going to be using my namespace std just in order to keep my project look a little bit more readable, like I said. We're going to do a cout, and we are going to say what is basically going to be a long line here, and then we're going to do another cout again. We're going to do a tab character, like I mentioned before. This is usually about, I think it's like 4 to 8 spaces, and then we're going to say welcome. We're going to do an end line up here as well. So we're going to do end line, and then we're going to do an end line here, and then we'll do the same thing again, basically. All right, so we'll duplicate that. And then in addition, I'll do 2 new line characters to create some space after that. We can do 1 because the end line is going to do a new line character as well. And then we're going to say cout, what is your name? We don't need to yell at them. Do endl. I'm going to move it above this to do because I'm not necessarily doing this to do yet. So we'll get to that. Cursor's getting a little weird. There. What's your name? Then we'll prompt the user for a name. You guys have probably seen me do this a few times already. So we'll say name space not end the line, and then we'll do a cin. We'll store a name here, right? So we'll declare a name variable, but we want to actually define it, and then we'll say cin over to the name variable, right? And then we'll say after that we'll do a cout, and we'll say how about some new lines? So 2 new lines. I think I'll say, how old are you? Question mark. So endl, and then we'll do a. We can store this as a string for now. So we'll say string age, and we will then say. Oh, sorry. We'll do that. We'll do cout, and then we'll say age. We'll do the prompt there. Then we'll have our placeholder variable. We'll do cin, store that age. And then finally, we'll say cout, and we'll do also new line again. And we'll say hello, name, who is age, years old, right? And just for sanity purposes, we'll just walk through it, right? Welcome, what's your name? Doug, age, 38. Hello, Doug, who's 38 years old. Cool. So that's a good looking application. However, we do have some duplication here, right? Obviously, we're doing this whole process twice. This might be something we want to reuse, and maybe we'll have something else here, right? We can do, come here, we'll do a cout, also a divider, right? So we'll do just like a single divider like that, right? So it kind of creates some separation between that and that. And also, we could probably now that we do that, move these new lines. So I'm going to say this divider is going to be new line, and then new line. Right? So I can remove this line there, those lines there. Right? So clean that up a little bit. But did recognize some kind of duplicated code here. So if we want to clean this up a little bit, we can take some of this stuff that we're duplicating and encapsulate it into a method. I think the dividers are a good use for this. We could put them into a variable, but if we want to use them in places, it might be better to display them as some kind of method. Now, what I could do is I could just come down here and I can say, give it a void return type, and then say display divider. So we'll talk about that return type in a second. So every single method that we type, right? So this is the type of value that the method will return. Now this particular method is just displaying a divider, so it doesn't necessarily need to return anything, right? It just needs to display something. As a result, we still need to define some type of return type. In our particular case here, that return type is going to be void, which means no return type. Now that I've done that, I can take this C out here,